Number 4. Which is the graph of the function g of x equals negative 1/3 x squared plus x plus 6? So this question is asking you to match g of x to the graph below. So it's definitely a quadratic because it has an x squared. And there's two really easy giveaways for this one in this particular case. The first one is that there is a minus sign out front, and we know that a minus sign in front of a parabola, it means that it's automatically going to open down. So already answer D is our answer. The other dead giveaway is the y-intercept. So we know we have ax squared plus bx plus c is a quadratic, and c equals our y-intercept. So in this case, our y-intercept is 6, and this is the only graph of the y-intercept is 6. So those are the first two things you should always check when you're matching the graph of a quadratic. Number 9. The function h of t equals negative 16t squared plus 32t plus 128 represents the height of a cannonball in feet, t seconds after it is shot from a cannon. How many seconds does it take the cannonball to hit its target on the ground? So this problem is in the non-calculator part. So you have to do this problem without a calculator. So when we're asking how long it takes something to hit the ground when it's modeled by a quadratic, we need to factor. So in this case, we want to know when it hits the ground and how many seconds it hits the ground in. So if we know h usually represents our height and t represents our time. So we're looking for the t value. So if it's hit the ground, the height is 0. So we're going to plug 0 in for h of t. So 0 equals negative 16t squared plus 32t plus 128. So in order to do this, we need a factor. To factor this, we first check for a GCF. And there is a GCF of negative 16. And you could just do 16, but then we'd have a negative t squared. If we pull out the negative 16 as a GCF, well, a positive t squared, and we could use big X. So we're going to pull out negative 16, and that's going to leave us with t squared plus, I guess if we pull out the negative, it's going to leave t squared minus 2t minus 8. And how I got those numbers is I just divided everything by negative 16. So now, once we have that, we carry along the negative 16 out front, and then we need to factor what's in the parentheses. And we can do that by using our big X method. So negative 8 goes on top, negative 2 on the bottom. And we need to know what multiplies to negative 8 and adds to negative 2. So we know 4 times 2 multiplies to 8. But we need a negative 8 and a negative 2 on the bottom. So we're going to make that 4 negative, because negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So in my parentheses over here, I have x minus 4 and x plus 2. And I'm still not done, because it didn't say just factor. It says how many seconds did it take the cannonball to hit the ground. So we know this still said equal to 0. So now I have 3 factors, negative 16, x minus 4, and x plus 2. And I need to set each one of those equal to 0. So I do negative 16 equals 0, x minus 4 equals 0, and x plus 2 equals 0. So when I do this, negative 16 can't equal 0, so we obviously know that's automatically not our answer. X minus 4 equals 0, we add 4 to both sides, and we get x equals 4. And on this one over here, we subtract 2 from both sides, we get x equals negative 2. The problem with having x equals negative 2 is that we can't have negative seconds. So we automatically know, that's supposed to be a negative 2, that that's not our answer. So our answer is x equals 4 seconds. 19. Suppose that the equation v equals 40x squared minus 500x plus 5,000 describes the value of a car from 1960 to 2012. What year did the car have the least value? X equals 0 is 1960. In this problem, what we're going to need to do is take the quadratic equation and plug it into our calculator and look at either the table and find out where our lowest value is. So to do that, we're going to go in our calculator, and we're going to click y equals. We're going to plug in 40x squared minus 500x plus 5,000. And we're going to press second graph. And as we look, so in 1960, where x equals 0, because that's what it tells us at the end of the problem here, it looks like the car was worth $5,000. And we could have saw that because we know our y-intercept is 5,000, so that's where x is 0. And if we scroll down, we can see where the least value is and what year that will correspond with. So we're going to keep on going until we start seeing it rise again. And it looks like at 3,440 is the lowest value before it starts to rise again. So $3,440. But we want to know what year, so we know that's an x value of 6. So if 0 is 1960, then 6 years later would be 1966. So our answer will be B.